I'm doing it. I'm making a video. I just came in from Brooklyn a few hours ago and I have my kids running around the house, so I'm doing this because I love you all, and if you hear children breaking into the room, well, you've been warned. What I'm going to do is, on the test I wouldn't ask you to find the second derivative, I would just ask you to find the first derivative. So let's just do that part. If I'm taking the derivative using implicit differentiation, this is what I do. I ddx both sides. So I'm going to write that out. ddx, 2x minus y squared. Oh, it's 2xy minus y squared. Oh, that complicates things significantly. 2xy minus y squared equals 3. When you do that, and remember you ddx both sides, so already I'm off to a thunderous start. ddx both sides, that will look like this if I wrote it all out separately and made it look a whole lot better than it currently does, so I'm just going to do it anyway. If you ddx a number, you get 0, so that's easy. And of course there's y squared here too, so again off to a thunderous start. ddx both sides, that means you ddx each thing. If you take the derivative of a y value, as long as it's with respect to x, you take the regular old derivative, but you have to attach a dy dx. So the way I have to start this out is I have a 2x times a y, which means I have to use the product rule. So u equals, let's let it be 2x because that'll be my u, and so my y will be y, or v will be y. U prime is 2. V prime is the derivative of y is 1 attached to a dy dx. So really it's not 1 dy dx. If you want to clean it up, make it regular old dy dx. Okay, so this chunk right here is going to be u prime v, which is 2y plus v prime u, which is dy dx times 2x, or 2x dy dx. So that's this part. Okay. Minus the derivative with respect to x of y squared is going to be minus 2y, and since I took a derivative of a y value, I have to attach a dy dx. Okay. Still equals 0. Step 2 is you factor out all the dy dx's and move all the non-dy dx's to the other side. So these two guys are attached together. If I subtract 2y from both sides, I get 2x dy dx minus 2y dy dx equals negative 2y. Factor out the dy dx, and that leaves me with the 2x minus 2y equals negative 2y. Divide everything by the stuff that we are left behind after we factored out the dy dx. So divide everything by 2x minus 2y, 2x minus 2y. Cross that out because it's gone now. And our answer is going to be dy dx equals negative 2y over 2x minus 2y. No, you cannot cross out the 2 y's because we're subtracting down here. That's it. If I were to take another derivative, I would do the same exact thing. It would be quotient rule. It would be a mess, but I wouldn't make you do that on the test, so I'm not going to make you do it here. All right, the second problem, problem 18 from page 229. I'm simply being asked to find the derivative of y equals ln x squared. Chain rule, take the derivative of the outside, which means you bring the 2 down. That becomes 1. I'm really bad at this. Keep the inside. Take the derivative of the inside, and remember the derivative of ln of x is 1 over x. So multiply everything by the derivative of the inside, which is 1 over x. And all we have to do is combine 2 ln x over x. Done. Done, 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 done. All right, problem 25, same exact rules. Take the derivative of y equals e to the ln of stuff. Fun fact, Probably remember this from pre-calc. Every single one of you remember everything you learn in pre-calc. E to the ln of, I don't know, smiley face equals smiley face. In other words, if you have e to the ln of stuff, the e and the ln just cancel each other out and you're just left with stuff. So, e to the ln of x squared plus 1, the e and the ln cancel each other out and you're left with x squared plus 1. Which means the derivative is 2x. Look at that. See? Isn't that easy? Fun. Okay, page 284. There it is. A rectangular field is to be bounded by a fence on 3 sides and by a straight stream on the 4 sides. Find the dimensions of a field with maximum area that can be enclosed using 1,000 feet of fence. So these are my 2 parameters. I have an x, a y, and an x. Okay? I know that my perimeter, which is normally found by 2y plus 2x, is actually 1,000. Alright, sorry, I had to stop the video because my son was yelling because the door needed to be closed. You know, kids. Alright, so anyway, I have my straight stream, I have my 3 pieces of fence, which I know total up to 1,000. I have 3 pieces of fence here, so 2 of these x's plus a y is going to equal, not 100, but 1,000. I also know that area, which is what I have to maximize here, is always found if it's a rectangle by multiplying your length times your width, or in my case, x times y. If I solve everything for y, which seems to be the easiest to do, I get y equals 1,000 minus 2x. So knowing that, and knowing that my area is what I have to maximize, I can say that a equals x times 1,000 minus 2x, or a equals 1,000x minus 2x squared. If I'm trying to find out what I'm maximizing, I need to come up with some boundaries, and I need to come up with some critical points. So let's do the critical point first, okay? My critical point is found by taking my area, the thing that I have to maximize in this case, taking the derivative, so that'll become 1,000 minus 4x, setting the derivative part equal to 0, so 1,000 minus 4x, and solving for my x. So if I add 4x, I get 4x equals 1,000. And x equals 250. So my critical point is x equals 250. Now what I also have to do is I also have to find the maximum and the minimum number that I could use for any of these things. Those are called my endpoints. Now my minimum number, and this is how I would write it out in class if you remember, is 0. I have to make, if I'm going to have a length, the smallest it could be is like just a little bit more than 0. The largest it could be is 333.33. Actually, no, I take that back. The largest it could be, if I'm using x, which seems like that's what I want to do because I'm doing x, is I can't make a fence length any longer than 500. If I go over 499.9999, go up like that tiny little bit and go over 499.9999, that's the biggest I can do. So my other endpoint is 0. So the x's that I'm going to use, and I'm going to write over here, that I'm going to plug into my original equation are 0, 250, and 500. My original equation, once I had it written down, was 1,000x minus 2x squared. So let me quick write that down. My original is 1,000x minus 2x squared. If I plug in 0, let's save a lot of time. I'll get 0 minus 0, so if I plug in 0, I get 0. Likewise, if I plug in 500, I'm also going to get 0. If I plug in 2,000 or 250, that becomes 250,000 minus 250 is 245 is 6. I think it's that. I'm pretty sure it's that. And you guys can correct me. Either way, I don't get 0. And either way, that's not part of the question. The question was, what are the dimensions of the field with the maximum area? So whatever number that is, it sure is a whole lot bigger than, it's not 0. It sure is a whole lot bigger than 0. Okay, so if x is 250, right? If x is 250, that's my maximum. Y can be found by doing 1,000 minus 2x, or y is 1,000 minus 2 times 250, which ends up being 500. So the maximum area in this problem is 250 feet by 500 feet. And I thought I ran out of paper there. There we go. See? Perfect. Perfect. All right, problem 18 on page 295. This is how we ended class, I believe.
Calculus.
Yes, I'm teaching calculus, Angel. Problem 18 is a big one. 2 to the 4th minus 4t squared plus 4. Part A says I need to find the velocity and acceleration. Velocity is the first derivative. Acceleration is the second derivative. And if I ever get to that point, which I'm sure I will, the speed is going to be the first derivative, but you take the absolute value of it. So the velocity function, I'll put vel there, is going to be 4t cubed minus 8t plus 0. The acceleration function is going to be that double prime, which is going to be 12t squared minus 8. That's part A, actually. I don't have to plug anything in. Those are my two functions. First derivative, second derivative. Part B is find the position, velocity, speed, and acceleration. I almost said felicity. Oh, 90 show, you kids wouldn't get it. The position, velocity, speed, and acceleration at t equals 1. Position is going to be s of 1. Velocity is going to be s prime of 1. Speed is going to be the absolute value of s prime of 1. And acceleration is going to be no absolute value. As a double prime of 1. Yeah. So position is s of 1, which means I use the original function. So that would be 1 to the 4th minus 4, 1 squared plus 4. That would equal 1 to the 4th, which is 1, minus 4 times 1, which is 4, plus 4 equals 1. So my position is 1, do I have a unit? Feet. 1 foot. 1 foot. How many feet do you have?
2.
That's right. But the position here is 1 foot. The velocity is going to be the first derivative, throw in that 1, so it would be 4 times 1 cubed minus 8 times 1. That's going to end up being 4 times 1 minus 8. My velocity is negative 4 feet per second, which means I'm going backwards 4 feet. That would mean that my speed is the absolute value of negative 4, which is 4 feet per second. And my acceleration is going to be 12 times 1 squared minus 8, which is 12 minus 8, which is 4 feet per second squared, which means I'm speeding up. I have a feeling that's what C is going to ask us to do. C is what time is the particle stopped? Nope, just kidding. The particle is stopped when the velocity is 0. The velocity function was 4t cubed minus 8t. So if I set that equal to 0, 0 equals 4t cubed minus 8t. Babe, what are some words that start with the letter T?
Turtle.
That's right. You're so smart. You're very smart. Almost as smart as I am. So I have, all right, what was I doing? All right, so I pulled out a 4t. That left me with t squared minus 2, which means t equals 0. And I'm going to set this guy equal to 0. What's up, buddy? Okay. What, are you getting something to drink? Look, and there he goes. Oh, children are truly the greatest. All right. All right, so my time. Great, my pencil just died. Well, everything's working. You kids wanted this video, so here you go. My time is going to be plus or minus square root of 2. You can't have negative times, so we're going to get rid of the plus or minus part. My time is the square root of 2.
Don't worry, baby.
What'd you say? Did you say don't worry, baby?
Don't worry, baby.
You are the cutest little
Don't worry,
thing.
baby.
You don't worry, baby. That's it. So, oh, no. I'm trying to find out where it's speeding up and slowing down, right? No, it's just asking where it stopped. So, yeah, it stopped at 0 seconds and the square root of 2 seconds. Which is over here. What's up, muscles? Daddy's making a video about math. And now you're part of it. Oh, then go sleep. Oh my goodness. When is the particle speeding up or slowing down? All right, so the particle is speeding up or slowing. What happened? Is it broken?
Yeah, let's fix it.
I can't fix it. We have to take it back to the Play-Doh store. All right, it's speeding up or slowing down when the acceleration is positive or negative. Then go get mommy then. What did Daddy tell you he was doing? Daddy is... Yeah, I'm doing calculus. All right. Where was I? All right, so speeding up or slowing down, what I have to do is I have to take my acceleration function and I have to find out when it's positive or negative. So if I set the acceleration function equal to 0, 12t squared minus 8. Okay, here it is. Solve for t. Add 8 to both sides. Divide 12 from both sides. That simplifies to 3 over 4, right? Nope. That simplifies to 2 over 3 equals t squared. Square root both sides. Normally I'd throw a plus and minus there, but there's no such thing as negative time. So what I get is 2/3. What I do is I make one of these fun little charts that we made. Put 2/3 there, or the square root of 2/3 there, which I don't know what the square root of 2/3 is off the top of my head, but I know 1 is bigger than it and 0 is smaller than it. So if I plug 0 into that function, I get something that's negative. If I plug 1 into that function, I get something that's positive, which means it's slowing down before root 2/3 and speeding up ahead of root 2/3. So my answer is it's speeding up when x is greater than root 2 over 3 seconds. What, babe?
That is the letter A.
Calculus is math, and it is the best math of all. All right, last thing that I have to do is I have to find how much it traveled. So the total distance between time is 0 and time is 5. I'll put that here. So what I do is I take s of 5 minus s of 0. That is how I find my position. I take my final spot and I subtract out my original spot. If I plug in 5, let's see if I can do this without a calculator. I get 5 to the 4th, which is 625, minus 4 times 25, which is 100. So 525 plus 4. 525 plus 4 is 529, minus plug in 0. And I get 0 minus 0 plus 4. So I have traveled 225 feet. Well, that's what happens when you have 3 kids and they just won't let you record anything. That one problem took 10 minutes, but it's all there. It's all there. Page 310 to 314, number 4, second to last problem. What am I doing? Find the intervals which f is increasing, the intervals which f is decreasing, the open intervals on which f is concave up, and the open intervals which f is concave down, and the x-coordinates of all inflection points. All right, so let's see if I remember that. A is increasing. What I have to do is I have to take 4, which is f of x equals x to the 4th minus 8x squared plus 16. I have to take the derivative of it, which gives me 4x cubed minus 16x plus 0. Set it equal to 0 and solve for x. This gives me the critical points. So if I do that and pull out a 4x, I'm left with x squared minus 4. 0 equals 4x. This is difference of squares, so I'm going to factor that out. X is going to be 0, negative 2, and 2. 0 for that guy. Sorry, 0 for that guy, negative 2 for that guy, and 2 for that guy. So I'm going to make my thing. I'm going to make my f prime line increasing, decreasing thing. Okay. I care about when the action happens at 3 spots, negative 2, 0, and positive 2. So I'm going to plug in like negative 3, negative 1, 1, and 3 into my f prime function. That'll tell me where it's increasing or decreasing. If I plug in negative 3, I get a 4 times boy, I really wish I had a calculator at this moment right now. If I plug in negative 3, what do I get? Positive or negative? Let's plug it in here. I can always plug it in there. That'll become negative, that'll become negative, and that'll become negative, so that'll stay negative. If I plug in negative 1, that's a negative, that's a positive, and that's a negative, so positive. If I plug in positive 1, that's a positive, that's a positive, that's a negative, so negative. And if I plug in 3, I get 12 times 5 times 3, which is positive. So combining A and B. I know A is asking for increasing, and B is asking for decreasing. It's increasing between negative 2 and 0, and 2 higher than 2. So it's increasing between negative 2 and 0, and also when it's greater than 2. And it's decreasing when it's less than negative 2, and it's in between 0 and 2. Does that make sense, honey? Yeah, you got that? Not or equal to. Don't include that. Don't include the or equal to. Because it's doing neither. Okay? It's constant at that moment.
Yes.
How many fingers do you have?
10.
You're ready for this class. All right. So that takes care of the AB part. I need to find, what else do I need to find? Concave up, concave down. So we're going to skip the inflection points part because that kind of answers this. I care about when it's concave up or concave down when I have f double prime. So if f single prime was 4x cubed minus 16x, f double prime is going to be 12x squared minus 16. 0 equals 12. Let's factor out a 4. And that's all I really can do. So that really doesn't help. So let's not do that. Let's not do that at all.
Have this.
What, baby?
You use count. You use 1.
Mm-hmm.
2.
Mm-hmm.
3.
Mm-hmm.
4.
Mm-hmm.
5.
Mm-hmm.
6.
Mm-hmm.
7.
Mm-hmm.
8.
Mm-hmm.
9.
Mm-hmm.
10.
Mm-hmm.
And you let him remember. You say A, C, D, E.
Mm-hmm. Keep going.
A, B, C, F, G, H, I, J, K, L, M, N,
Don't forget the plus or minus. WX. Oh gosh. Next time, won't you? Oh, gorgeous. Your singing is that of an angel. Mm-hmm. So what I did is I took the second derivative, set it equal to set it equal to 0.
What are they?
Those are people. I think you made them. Set it equal to 0. Added
AI.
16
What's
divided by
this?
12. Take the square root, simplify, and that's what I get. Those are actually the x values. So this is the answer to part E. Actually, the inflection points are when the second derivative is equal to 0. What?
And it's I.
It is I. You are very smart.
Is it A, B, C, D, E, F, This is how comes the ABCs.
Mm-hmm.
Hey,
Yeah.
it's the other eye.
All right, so I now care when it's concave up, which means the second derivative is positive, and concave down, which means the second derivative is negative. So, all right, I know my inflection points live right there, so I'm going to make the second derivative line thing. I care about what happens at negative square root of 4/3, yes, and positive square root of 4/3, which means in between numbers would be 0. Let's do 10 and negative 10, because why not just plug things in? Oh my heavens. If I plug in negative 10, that'll be 120, or that'll be, yeah, negative 10 squared is 100. 120 times 100 minus, so that'll be positive. If I plug in 0, it'll be negative. If I plug in regular 10, it'll be positive, which means concave up here, concave up here. So anything that is smaller than the square root of 4/3, concave up. That was what C wanted, right, when it was concave up? Concave up when everything is smaller than... Mommy's in the bedroom watching Jurassic Park. Terrorizing your mind with violence.
Where's Owen?
Owen? Star-Lord? Star-Lord. Star-Lord's a rap music person that you're not allowed to listen to. All right, so concave up here and here, which means everything less than root 4/3 and greater than root 4/3, and it's concave down where everything is in between that. So x is going to be in between negative root 4/3 and positive root 4/3. Use any method to find the relative extrema of the function of f. Relative extrema happens at the critical points. I'm not doing the absolute, I'm doing the relative. So all I have to do is just take the derivative.
I like it.
Set it equal to 0.
That is mine.
You're allowed to have it. Bring out a 4x. That's difference of squares.
Open it.
What, babe?
Daddy, open it.
This problem I'm going to be done in about 1 minute. Can you wait? You're an angel. What am I doing? Just use any method to find the relative extrema. So I need to find out what they are. What am I doing? You tell me.
What are you doing?
You tell me.
What are you doing, Dad?
I'm doing calculus.
Whoa.
All right, so my relative extrema happen at 0, -1, and 1. In order to find what those exact points are, I'm going to plug in 0, -1, and 1 into the original function. So f of 0,
Daddy, do that.
f of -1, f of 1 is going to be, let me see, if I plug in 0, I get 7. So f of 0 is 7. F of -1 is 1 minus 2, which is -1, right? 1 minus 2 plus 7, which is 6.
Daddy,
Yeah, babe.
what do you want to eat?
What do I want to eat? Make me a pretzel, please. A Play-Doh pretzel. And if I plug in regular one...
I make a snake.
Oh, I'm not going to eat a scary snake. Yuck. Yuck. All right, so I have a bunch of points here. 0, 7, -1, 6, 1, 6. Since that's a larger number, that's going to be a relative max. That's going to be a relative min. And that's also going to be a relative min. All right, that should do it. Video's done. Test is going to look like all of that. Say bye.
Bye.